Good morning, everyone. Our today's topic is depth of field. Depth of field is the zone of acceptable sharpness in the photograph. So, whenever you focus your lens at any given subject, at any given object, there is some distance before that focused point and some distance beyond that focused point which is acceptably sharp. And this zone of acceptable sharpness is called the depth of field. Look at this picture now. You can see the dog is very sharp, but the background is blurred. This shows a shallow depth of field. This shows a deep depth of field. Everything from the foreground to the background is acceptably sharp. Here's another example of deep depth of field. Look at the car, the number plate, and the structure right behind in the background. Everything is pin sharp. So this is deep depth of field. Now, in general, when we are talking of general photography, that is non-macro photography, so out of the total depth of field available, 1/3 is sharp in front of the focus point, while 2/3 is sharp beyond the focus point. Keep in mind that depth of field change from picture to picture unless you have the same exposure and you are shooting from the same position, then it will not change. But otherwise, for every picture that you take, the depth of field will change because you keep on changing your apertures, your shutter speeds, your focal lengths, whatever. So keep this in mind that out of the total depth of field available, 1/3 is sharp in front and 2/3 is sharp beyond the focus point. When it comes to macro photography though, out of the total depth of field, the depth of field extends equally on both sides of the focused point. In other words, it is not 1/3 and 2/3 as it is with general photography, but it is half and half. Factors governing depth of field. First is the focal length. Wider the focal length, greater is the depth of field. Longer the focal length, shallower is the depth of field. Then we take aperture. Narrower the aperture, like 11 and 16, greater is the depth of field. Wider the aperture, like f2.8, f2 1.4, shallower is the depth of field. Third, and the most important thing according to me, is the distance between the lens and the subject. Shorter the distance, shallower is the depth of field. Greater the distance, greater is the depth of field. Now let's see this in another way, graphically now. In this case, you can see that the aperture and distance are constant. You can see on the left hand side over here that the focal lengths are different, but the aperture though not mentioned, you can take it from me that it is kept the same and the focus point is the same. This is the center line, that is the point of focus. Now, when the aperture and distance are constant and only the focal length varies, in that case you will find that the depth of field is maximum with the 24 mm lens in this example. Also observe that it's 1/3 and 2/3. Though my drawing may not be exactly showing that, keep in mind from the focus point it is 1/3 in front and 2/3 behind, but out of the total depth of field. Now we can see with 50 mm lens that has reduced, and with 100 mm lens it is still reduced. When focal length and distance are constant, now you can see that focal length is marked as 100 mm, all the three lenses, three cameras, and this is a 2.8, 5.6, 11. That means only the aperture changes, even the focus distance is the same. With this in mind, you will see that the narrow aperture gives you the maximum depth of field. Again remember, from the total depth of field, 1/3 is sharp towards the camera, 2/3 is sharp behind the subject. And you can see now with 100 mm lens, it's a very shallow depth of field. 1/3 this side, 2/3 on the other side. When focal length and aperture are constant, all the three cameras have the 50 mm lens and the aperture is also identical, f5.6. Only the distance varies. So here you can see that with the maximum distance, there is maximum depth of field. So as you go close to your subject, depth of field will be shallow. When you go away from the subject, depth of field will be greater. This is an interesting corollary. Let's say you have three lenses, 50, 100 and 200 mm, and let's further assume that they provide identical magnification on the imaging sensor. Of course, the three lenses will have to be at different distances from the subject to do that. Now, which lens will provide the least depth of field? If your answer is 200 mm, you would be wrong. All three lenses will provide exactly the same depth of field since the magnification they create is the same. Did you know that depth of field at a magnification of 1:1, that is life size, even at f16 is just around 3 millimeters? Did you know that the depth of field tables are based on print size of approximately 8 by 10 inches? When you want to print larger, you must use a narrower aperture than what is shown on the depth of field table. So till we meet again, keep this in mind. Happy shooting.